Alright, for this problem we have a crate that is a cube and it is 1.2 meters on a side, and its geometrical center then would be 0.6 meters up, and we're told that because of a piece of equipment inside of it, the center of the mass of the crate plus its contents is actually up at 30 centimeters higher, 0.3, so the total of 0.9 meters up, right? Center mass is 0.9 meters up. And the question is, as we tilt this crate, does it tip over or slide at as the angle theta is increased from 0? Right, as theta is increased from 0, does it tilt over or slide? And so let's say in the first case, coefficient of static friction is 0.6, right? It's 0.6. So let's think about let's think about a couple of things. One, the center of mass is up at 0.9 meters, right? And 0.6 meters horizontally over to there. So if you're going to construct a triangle here, that angle would be inverse tangent of 0.9 over 0.6. So let's get that real quick. All right, equals a tan of 0.9 divided by 0.6, and we're going to have to convert that to degrees. So 56.3 degrees. All right, 56.3 degrees. So think about it this way for a moment. If we tilted that's this angle, right, is 56.3 degrees, which means the angle between the vertical in here is 90 minus that, which is 34 degrees. All right, 34 degrees. So once we tilt the plane by 34 degrees, the center of mass, right, is actually straight up from this corner. All right, center of mass is going to be directly above this corner. All right, so let's calculate a couple of things. Let's ignore the tipping for the moment and just look at what angle would the crate slide. All right, if you remember, if we just talk about a crate sliding down a plane, the force down the plane is mg sine theta, right? And the frictional force keeping it going is mu s mg cosine theta, right? And so when we ask the question, where does it begin to slip, we're really talking about where does mu s mg cosine theta equal mg sine theta, right? Which really comes down to sine divided by cosine is tangent. Theta equals mu sub s, right? So in the first case where tan theta is 0.6, take the a tan of 0.6, convert that to degrees, and we get 30.9 degrees, right? So in part A, we know it begins to slip at theta equals 30.9 degrees, right? Which is equals inverse tangent of mu sub s. All right. All right. So it begins to slip, and theta is 30.9 degrees, which is the inverse tangent of mu sub s. Okay. Does it tip before then? All right. Does it tip before then? So let's look at it at that point. At what point does it tip? Right? It tips at the point. Okay. So we have, if we look at rotation about this point, right? Rotation about this point, we have two things keeping it in place. And this, we have two torques. We have mg sine theta, right? Mg sine theta is times 0.9 degrees, 0.9 meters, is the torque due to the component of the weight down the slope about this point, right? Because it's the perpendicular distance. All we're worried about is this. And then over here we have mg cosine theta. And in this case, its distance to the pivot point is only 0.6 meters, right? So this thing is a little top heavy. Its distance is only 0.6 meters. So at the point where these two are equal, it's ready to tip. So let's put that together. All right. So it's going to tip when, oops, as always, when I accidentally do that, it bugs the hell out of me. Oh, come on. All right. Let me just label this onset of slipping. All right. Now let's go here. Let's do onset of tipping. Onset of tipping is when mg cosine theta times 0.6 meters, right, equals mg sine theta times 0.9 meters, right? And so that gets us to, we're looking at tangent of theta equal to 2/3, right? When tangent theta equals 2/3, which is theta equal to, okay, so a tan of 2/3 degrees, that, so 33.4 degrees, which is the point at which the center of mass is directly over that pivot point. So the question in part A, does a crate tip or slide? The answer is the crate slides, right? The crate slides because it hits the point at which it slides, 30.9 degrees, before it hits the point at which it tips, 33.4 degrees. Part B is what angle theta does this occur? Well, okay, we got that, 30.9 degrees. 30.9 degrees. Oh, pardon me. All right, we'll just copy this down. Part C. Does a crate tip or slide if the coefficient of friction is 0.7? So part C, in part C, we're looking at theta at which it slides is theta slide equals a tan, right? Again, a tan, inverse tangent of 0.7. Okay, so equals a tan of 0.7 degrees of that, 34.99 or 35 degrees. So it would begin to slide at 35 degrees, but you notice up here, the point at which it begins to tip is independent of the coefficient of friction. So in part C, it will tip at, right? And then part D is tips at theta, missed that, theta equals 33.4 degrees. All right, theta equals 33.4 degrees at the point at which it tips. And I believe that is it for this problem.